All right, we'll come back to the fourth lesson of this unit. And last time we looked at the slope-intercept form of linear functions. Today, we're going to be looking at the slope point form of linear functions. But actually, before we do, let's quickly review. Slope-intercept form, recall, was y equals mx plus b, where m is the slope and b is the y-intercept. So here are two questions. Give it a try. Okay, so the first one, it tells us the slope is 9 over 5 and the y-intercept is -2. So that means m, the value of m is 9 out of 5 and the value of b is -2. So again, plug in the values for m and b into the form. You should get y equals 9 over 5x minus 2. Okay, so that one was pretty easy because everything was given to us. For part B though, we need to actually find the slope ourselves. Okay, so let's see here. We have a good point right here. And it looks like we have another good point right here. Okay, so we can count the slope. So here we go. Recall slope is rise over run. So that's 1, 2, 3, 4, 5. So the rise is -5. 1, 2, 3, 4, 5, 6. 6 to the right. So the slope is -5 over 6. The value of b is the y-intercept, which is the point right here. That is -1. So now we have the value of m and value for b. We then have the equation -5 over 6x minus 1. Okay, so that was slope-intercept form. Again, today we're going to be looking at the slope-point form. Some people call this the point-slope form. It's the same thing, really. Okay, so slope-point form of the equation of a linear function. Okay, the equation of a line that passes through the point P and has a slope m is this equation. Okay, it says y minus y1 equals m times x minus x1. So the x1 and y1 are simply just the x and y coordinate of a point. Now, it could be any point you want, okay? So it doesn't have to be P, it could be Q here if you want it, and then we just call that, x2, y2, it doesn't really matter. But we can still plug in the x2 here and y2 there, okay? So as long as this point is on the line, you can use that point and the slope to figure out the equation of the line, okay? So the x and the y's here, they are just like our x and y here. They are always just x and y, they don't change. However, y1 is a value, x1 is a value, and m is the slope, obviously, so that is also a value, okay? So that's the slope point form. Let's take a look here. It says, let's graph, okay? So describe the graph of the linear function with this equation. So here we know that the slope is going to be, so if you come, actually, you know what? Let me rewrite the equation or the form. It's y minus y1 equals m times x minus x1. If you compare these two equations, you see that the slope is 1 over 3. And we know that it passes through the point. So again, it's x1, y1. So here is x minus x1. Be careful here, it says x plus 4. So actually, x1 is not 4, it's actually -4 because x minus -4 will give you the positive 4. Okay, so even though we see x plus 4 here, but the x coordinate is actually -4. Similarly, for y1, if you just compare them, that's a minus sign, that's also a minus sign. That's perfect, they have the same sign, therefore y1 is just 2. Okay, not -2, because if it was -2, then it would be y minus -2, and that would turn into a y plus 2. But we do have y minus 2 here. So there's our p. Let me figure out where that is. -4 and 2. 1, 2, 3, 4, and 1, 2 here is my point P. We know the slope is 1 over 3, so we're going to go 1 up and then 3 to the right. 1 up, 1, 2, 3 to the right. Okay, and again, from there, then you just take out ruler and then join the points together, and there is your linear function. Okay, so why don't you try the next one here and see if you can graph it, okay? Okay, so this one shouldn't be too bad. The slope is -1/2. The point P is going to be, again, x1, which is 2, and y1 this time is -1. Okay, so 2 and -1 is right here. The slope is -1/2, so we're going to go 1 down, 2 to the right. 1 down, 2 to the right, or we can go 1 up and 2 to the left. Okay, that's enough points for me to draw a line. And there is my linear function. Okay, so again, you are just comparing this with the form y minus y1 equals m times x minus x1. Okay, so clearly m is negative 1/2. Again, that says x minus 2, that's x minus 1, sorry, x minus x1, so the signs are the same, so x1 is just the value you see, which is positive 2. Okay, even though that says x minus 2, right? Just be careful, it's just the opposite sign, right? Here you have x plus 1, but in reality, y1 is negative 1. Okay, so that was graphing, and now we are going to do the opposite. Okay, we're going to come up with the equation given the graph. Okay, it says write an equation in slope point form of this line. Well, we have 2 points that's given to us here. That's this one and that one. Let's find the slope. Okay, we can actually find the slope quite easily by just counting, right? Because we have the graph, we can just count. The rise is 1, 2, 3, and the run would be 1, 2, 3, 4. Okay, so the slope is 3 out of 4. Now, so to write the equation in the slope point form, that means we need to find a point. Now, we do have 2 points here. Does it matter which point we use? No, it does not. Okay, you can pick any of points on the line. Okay, so really you can use this point if you wanted to, but you know that point is not a nice point, so I wouldn't use that one. So technically you could use this or use that. Okay, it doesn't really matter. Okay, it doesn't really matter. They will give you the same result at the end. Okay, they will look different though, however, but they actually have the same meaning. Okay, so I'm just going to use 3, 1, because that's this point, because both are positives, so it's nice and easy to use. We then would have y minus y1. Okay, so here's our x1 and here's y1, so y minus 1 equals m, which is 3 out of 4, times x minus x1, which is a 3. Okay, so that's part A, write the equation in slope point form. Part B says write the equation in slope-intercept form. Okay, and what is the y-intercept of this line? You can see here, this is not a nice y-intercept. So if we wanted to write this equation in slope-intercept form, we can't do it right away because we just don't know what that is. However, if we come up with the slope point form first, then we can come up with the slope-intercept form. So let me just recopy the equation from the previous line here. The goal is to turn this into y equals mx plus b. Okay, so what we need to do is we need to isolate for y, and we need to get rid of the brackets. Okay, so what I'm going to do first is I'm going to distribute. Okay, so I'm going to multiply 3 over 4 with the x minus 3, so I end up with 3 over 4x minus 9 over 4. Okay, so that's 3 times 3, which is 9, and 4 is just the denominator. Remember, it's 3 over 1. So you multiply 4 with a 1. Almost done, right? This is actually quite close to that already. What we need to do is we need to plus 1 on both sides. Okay, so if I add 1 to both sides, this is a fraction. So to add 1, you need to add a fraction with the denominator 4, right? You need a common denominator. And therefore, you end up with 3 over 4x minus 5 over 4. And that is the slope-intercept form. And what's the y-intercept? Well, the y-intercept in this case is negative 5 over 4, because remember, that's the value of b. Okay, so that is how you do this. There's a practice question on the back page or next page. Give it a try. Okay, so slope point form. Again, we can count the slope. This is just going to be 1 down and 1, 2, 3 to the right. So that's the slope. Oops, negative 1 over 3. And now, again, we have 2 points. This time, actually, I'm going to pick this point. Okay, again, it doesn't matter which point you pick, and I'll show you the answer for both. Okay, let me use this one here first. This will be negative 2, 2. And if you use this point, that would be 1, 1. Okay, so if you use p, then the equation would be y minus 2. So it'll be your x1, y1. Let me call this x2, y2. Equals negative 1 over 3 times x minus x1, which is negative 2. So x minus negative 2 is x plus 2. Okay, x minus negative 2 is x plus 2. Okay, or you can write this as not y equals y minus y2 now in this case, y minus 1 equals the slope times x minus x2. which is also 1. And either way, it's fine. Okay, you'll get the same result if you expanded it. Okay, so that's fine. Part B says write the equation in part A in slope-intercept form. Okay, so this time I am going to do it with this one. Okay, so again, regardless of which one you picked for the part A, after you write it in the intercept form, the slope-intercept form, your answer should be the same. Okay, so let me just do it with this one. Okay, so again, first step, you need to multiply the brackets out. So then you get negative 1 over 3x minus 2 over 3. Okay, negative 1 times positive 2 is negative 2. Now we need to add 2 to both sides. So, and again, because the denominator here is a 3, so if I want to add 2, 2 turns into 6 over 3, right? So you plus 2 here, plus 2 here. And therefore, your final answer would be y equals negative 1 over 3x plus 4 over 3. And that'll be your final answer. And again, if you work from here, you should get the same result. Okay, so what's the y-intercept? Well, the y-intercept is 4 out of 3. Okay, hopefully it's not too bad. All right, let's try to do some more problems here. Here it says the sum of the angles s degrees in a polygon is a linear function of the number of sides n of the polygon. Okay, so the sum of angles s degrees is a function of the number of sides. Okay, so it's going to be s of n. Okay, the independent variable here is n, and s is the dependent variable. Okay, it says the sum of the angles in a triangle is 3 degrees. So if I make a table here, n and s of n, if I have a triangle which has 3 sides, the sum of the angle is 180 degrees. And then it says the sum of a quadrilateral, which means it has 4 sides, is 360 degrees. Part A says write a linear equation to represent this function. Okay, well, that's all we have. Okay, we have a small table of values, but that's all we need. Okay, because we can find the slope by using the formula y2 minus y1 over x2 minus x1. And let me just call this x1, y1, x2, y2, right? Because remember, the column on the left is the x column, and the column on the right is the y column. Okay, so y2 is 360 minus y1, which is 180, over x2 minus x1. So that's going to be 4 minus 3. If you simplify this, you just get 180. Okay, 360 minus 180 is 180. 4 minus 3 is 1. So 180 divided by 1 is just 180. So the slope is 180. And now we have 2 points, right? We can then put this into the slope point form. Now again, it doesn't matter which one you pick to put it in. Okay, actually, I'm not going to use y anymore. Let me rewrite this. Let me use, again, our x is equivalent to the n, and your y is equivalent to s. So I'm going to say s minus s1 equals the slope times n minus n1. Okay, so s, again, that doesn't change. S1 is a value. Let me just use 180 here. I guess I don't need a degree symbol there. The slope is 180. N minus n1, which is a 3. Okay, so there you go. That is your linear equation. Okay, now if we want to graph this, let's just what do we have here? We have the number of sides here, n, and this is the sum. So let's call the 0, 1, 2, 3, 4, 5, 6, and we'll go up by. Let's go up by 50 degrees. Why not? 200, 250, 300, 350, 400. Okay, so when it's 3 sides, the angle would be 180 degrees. That's somewhere here. When there are 4 sides, the angle would be 360. So that is right here. Okay, that really is all the points I have. Now, we should not join the points because the number of sides is a discrete variable. Remember, that means it cannot be broken down to a smaller part, right? You cannot have 3.1 sides. You can only have 1 side, 2 sides, 3 sides, 4 sides, 5 sides, but not 3.125 sides. It doesn't work that way, okay? So that's a discrete variable. So in that case, we don't join the points here. Okay, part B says, so that's the graph. Okay, that's all we have. That's fine. Part B says use the equation to determine E missing, the sum of the angles in a dodecagon. Okay, so it's a 12-sided polygon. Okay, so well, we just need to use the formula. S minus 180 equals 180 times n minus 3. It tells us it's a 12-sided polygon, so we just put 12 into n. Okay, so S minus 180 is equal to 180 times 9. S minus 180 is equal to 180 times 9 is 1620. And finally, to solve for S, you add 180 to both sides, so you get 1800 degrees. So in a 12-sided polygon, the sum of the angles would be 1800 degrees. Okay, good. So that's the first word problem. There's your practice question. Okay, see if you can figure it out. But actually, let me just say one more thing, right? The key, though, is to come up with this small table of values. Because once you have the table of values, you have 2 points, and therefore you can find the slope. And we do have 2 points here, and you can pick any point to put it into your slope point form. Okay, there you go. Give it a try. Okay, so the 2 points that we have. So here it says Celsius is a function of Fahrenheit. So F is our independent variable, and C, Celsius, is our dependent variable, so the y value. Okay, so the okay, my bad. I had to take a quick water break here. Okay, anyways, so we have the 100 degrees and 212 degrees Fahrenheit. Okay, that's the boiling point of water. They're equivalent at that point. The freezing point of the water in degrees Celsius is 0, and in Fahrenheit it is 32 degrees. Okay, so there's our table of values. To find the slope, again, here's my x1, y1, x2, y2. So you can calculate the slope. So we have y2 minus y1 over x2 minus x1. And that's going to be negative 100 over negative 180. Divide both numbers by 20, and the negative sign will cancel out. You get 5 out of 9. Okay, so that is the slope. So we have C minus, again, you can pick any points you want. In this case, actually, I'm going to pick the second point because, again, because the number is smaller. Excuse me, so C minus 0 equals 5 out of 9 times F minus 32. Now, you do have C minus 0, and C minus 0 really doesn't do anything. So you just leave it as C and F minus 32. Okay, and that is a linear equation for this function here. Okay, part B, it says use the equation to determine the temperature in degrees Celsius at which iron melts. And iron melts at 2795 degrees Fahrenheit. So all we have to do is plug in 2795 into F. So it's really C of 2795. That's okay. I'm not gonna write function notation here. So we're gonna replace F with 2795 minus 32. Okay, and now we just need to put this into calculator. Okay, it's pretty big of a number. 2795 minus 32 is 2763. Okay, now put this into calculator. You would get, let's see, divided by 9. You get 1532 degrees Celsius. Okay, hopefully you did just fine. Okay, we have last example here and a couple of practice questions for you to do. Okay, it says write an equation for the line that passes through the point 1, negative 2, and it is parallel to the line y equals 2/3 minus 5, 2/3 x minus 5. Well, if it's parallel to this, that means the slope should be the same. And we know that it goes through the point 1, comma, negative 2. There you go, we have a slope and we have the point. So y minus y1 should equal to m times x minus x1. And now you just plug in the numbers. Y minus negative 2 actually gives you y plus 2. m is the slope, which is 2/3, times x minus x1, which is going to be a 1. That is your equation. Okay. Whereas for part B, it's very similar, except it's perpendicular. Okay, so recall, if you have a perpendicular line to this, then the slope would just be the negative reciprocal of this line. Well, the slope here is 2 out of 3, so the negative reciprocal then would be negative 3 out of 2. So again, we now know the slope. We know that it goes through the point 1, negative 2. We then have the equation y plus 2 equals negative 3 over 2 times x minus 1. And there is your equation. Okay, and there are 2 last questions for you to try, and I'll show you the answer in a bit. Okay, so again, parallel means the slope is the same, which is going to be a 3, right? This is written in the mx plus b form. So the slope is m, which is, in this case, if you just compare them, is 3. The point S is 2 comma negative 3. So the equation will be y minus, well, negative 3, so y plus 3 equals m times x minus 2. There you go. For part B, it's very similar. It's perpendicular, so the slope should be negative reciprocal of that. Remember, 3 is the same as 3 over 1. So if you reciprocate that, it's 1 out of 3, and it's negative of that. So it's negative 1 over 3. That's the slope of the perpendicular line. And we know it goes through the point 2 comma negative 3, and therefore the equation would be y plus 3 equals negative 1/3 times x minus 2, and that is your final answer. Okay, so hopefully you're not finding this unit or this section in particular challenging, and if you need some help, let me know. Otherwise, you have some homework questions that you need to do. Okay, good luck.